This is Mr. Habtu, grade 12 mathematics teacher, and let's try to see some special limits. Let's take a unit circle. Remember that a unit circle is a circle with center 0, 0, the origin, and radius 1 unit. A unit circle is a circle with center 0, 0, and radius 1 unit. And remember the area of sector, area of segment. Sector is part of a circle. A sector is part of a circle formed by two radiuses of the circle and an arc. So that's the area of the circle. The area of the sector is given by pi r square theta over 360 degree. If theta is in degree measure, area is half r square theta. If theta is in radian measure, theta is the angle formed between the two radiuses. Here we have a segment. A segment is also part of a circle, the shaded region. So that the area is pi r square theta over 360 degree minus pi r square sin theta. Area of the sector minus area of the triangle. Or if theta is in radian measure, the area is given by half r square theta minus half r square sin theta. So in the given unit circle, we have triangle ABC. We have triangle ABD and a sector ABD. As you look from the graph, here we have the triangle ABD. The area of the triangle ABD is the smallest area. The area of triangle or sector ABD is rather smallest area rather than triangle ABC. Now let's compare the areas between the two triangles and the given sector. As you look from the picture, area of triangle ABD is less than area of the sector and less than area of triangle ABC. The area of the smallest triangle ABD, which is less than area of the sector ABD and less than area of the large triangle ABC. Now the angle theta is in radian measure, an acute angle between 0 and pi over 2. Let the angle theta is, or the angle x is an angle between 0 and pi over 2, acute angle. So area of triangle ABD, we can determine this area by the difference between the sector and the segment. Area of triangle ABD is area of the sector minus area of the segment. Area of the sector, so that if we subtract area of the segment from the area of the sector, we can get the area of triangle ABD. So area of a sector is given by half r square theta if theta is in radian measure. So that's half times r square times x. X is an acute angle x. So minus area of a segment is given by half r square theta minus half r square sin theta. So that half r square x, half r square sin x less than area of the sector. Area of the sector is given by half r square theta less than area of the large triangle ABC. Triangle ABC is a right angle triangle, so that the area is given by half times space times height. Half times space times height. Half times AB times BC. So that half times r square x less than half times AB. Here we have tan x, tangent of the angle x. Tangent of the angle x can be given by opposite over adjacent, which is CD over AB. So that AB is radius, and remember that radius of a unit circle is 1 unit. So that tan x is CD. So that half times AB. AB is the radius of the circle, which is 1 unit, times 1 times BC. BC is tangent of the angle x. So this is half r square x minus half r square x minus of minus plus half r square sin x less than half r square x less than half times tan x. Remember that the area of, the radius of a unit circle is 1 unit. The radius of a unit circle is 1 unit. So that half times the radius is 1 unit times sin x less than the radius is 1 unit. So that x over 2 less than tan x over 2. Multiply both sides of the inequality by 2. Multiply both sides of the inequality by 2. So that sin x is less than x over 2. Sorry, times 2, which is x less than tan x. Divide both sides of the inequality by sin x. So that sin x over sin x less than x over sin x less than tan x over sin x. Sin x over sin x is 1 less than x over sin x less than, remember that tan x is sin x over cos x. Sin x over cos x times 1 over sin x. 1 is less than x over sin x less than, we can cancel sin x by sin x, which is 1 over cos x. Find the reciprocal of the given inequalities so that 1 is greater than sin x over x greater than 1 over, the reciprocal of 1 over cos x is cos x. So that in order to find the reciprocals, the sign of the inequality will be changed greater than. Now take both sides of the inequality limits. Take both sides of the inequality limit. Limit of 1 as x approaches to 0 greater than limit of sin x as x approaches to 0 over x greater than limit of cos x as x approaches to 0. So the limit of a constant number is the constant itself. So limit of 1 as x approaches to 0 is 1, which is greater than limit of sin x over x as x approaches to 0 greater than, if we substitute 0 degree, so that limit of cos x as x approaches to 0 is 1, since cos 0 degree is 1 greater than 1. As you can see, limit of sin x over x as x approaches to 0 is in between 1 and 1, which is greater than or equal to. So we can conclude that limit of sin x over x as x approaches to 0 is 1. Limit of sin x over x as x approaches to 0 is 1. The other thing is limit of tan x over x as x approaches to 0. So this is limit x approaches to 0, tan x over x, or tangent of x is sin x over cos x, which is limit sin x over x times cos x as x approaches to 0, which is equals to limit x approaches to 0 sin x over x times 1 over cos x. So that limit of sin x over x as x approaches to 0 times limit of 1 over cos x as x approaches to 0. We already proved that limit of sin x over x as x approaches to 0 is 1. So this is 1 times limit of 1 over cos x as x approaches to 0. We can substitute 0 in x so that cosine of 0 is 1, which is 1 over 1. Therefore, limit of tan x over x as x approaches to 0 is 1. The third special limit is limit of 1 minus cos x over x as x approaches to 0. So, limit of 1 minus cos x over x as x approaches to 0. We can multiply by 1 plus cos x over 1 plus cos x, since 1 plus cos x over 1 plus cos x is 1. So, this gives us limits as x approaches to 0. 1 times 1 is 1. 1 times cos x is cos x. Cos x times 1 is cos x. Cos x times cos square is cos square x over x into 1 plus cos x. X into 1 plus cos x. So, limit as x approaches to 0. Here we can cancel cos x by cos x, so that we get 1 minus cos square x, 1 minus cos square x over x into 1 plus cos x, 1 plus cos x. Then remember that sin square x plus cos square x is 1. So, sin square x is 1 into cos square x. If we shift cos square x to the right hand side, 1 minus cos square x. So that we can substitute 1 minus cos square as 1 minus cos square x. So, limit as x approaches to 0. 1 times cos square x is 1 minus cos square x is sin square x. Sin square x over x into 1 plus cos x. Then this is limit as x approaches to 0, sin x over x as x approaches to 0 times sin x over 1 plus cos x, 1 plus cos x. Then remember that limit of sin x over x as x approaches to 0 is 1. So this is 1 times limit of sin x over 1 plus cos x as x approaches to 0. So we can substitute x so that sin 0 is 0, 1 plus cos x is 1 plus cos x is 1 plus 1, which is equals to 0. So we can say that limit 1 minus cos x over x as x approaches to 0 is 0. This is the third theorem. So we already proved that limit of sin x over x as x approaches to 0 is 1. Limit of tan x over x as x approaches to 0 is 1. The third theorem is limit of 1 minus cos x over x as x approaches to 0 is 0. This is all for the first part. So I will see you in the second part with some special examples relating to the 3 special limits. Thank you very much. Again, remember that limit of sin x over x as x approaches to 0 is 1. Limit of tan x over x as x approaches to 0 is 1. And limit of 1 minus cos x over x as x approaches to 0 is 1. And let's try to see some related examples, some related problems to the given theorems. to the given special limits. Here we have limit of sine 3x over x as x approaches to 0. We can express this as limit of sine 3x over x as x approaches to 0, as x approaches to 0. So that sine x over x as x approaches to 0 is 1. So we can make 3x and x equal, so that in order to make it equal, we can multiply by 3 over 3. Since 3 over 3 is 1, then this is 3 times limit of sine 3x over 3x as x approaches to 0. Since 3 is a constant number and limit of a constant number is the constant itself. So that this is 3 times, remember that limit of sine x over x as x approaches to 0 is 1. This can be given as 3. The second example is limit of sine 2x over twice of tan 3x as x approaches to 0. We can multiply this by any number which is, or by x over x, since x over x is 1. Since x over x is 1. So that we can make this limit as x approaches to 0, sine 2x over x tan to 3x over x. Since x can be cancelled by x, so that sine 2x over twice of tan x. This can be given as limit sine 2x over x as x approaches to 0 over twice of limit tan 3x over x as x approaches to 0, as x approaches to 0. So that we can multiply this by 2 over 2 in order to make 2x and 2x equal. Multiply this by 3 over 3 in order to make this 3x over 3x which is equal. So this is twice of 2 is constant number and limit of a constant number is the constant itself. Limit of sine 2x over x as x approaches to 0 over, here we have 3 is constant number. 3 times 2 is 6 times limit of tan 3x over 3x as x approaches to 0. So we have already proved that limit of sine 2x over 2x over 2x as x approaches to 0 is 1. 1 times 2 is 2. We already proved that limit of tan 3x over 3x as x approaches to 0 is 1. So that 1 times 6 is 6, which is 1 over 3. 1 over 3. The third example is limit of x squared minus 9 over sine x minus 3 as x approaches to 3. As x approaches to 3. So this is limit of x squared minus 9 is x squared minus 9 is x squared minus 3 squared. So that we can rewrite as x minus 3 times x plus 3. X minus 3 times x plus 3 gives us x squared minus 9 over sine x minus 3 as x approaches to 3. This is limit of x minus 3 over sine x minus 3 as x approaches to 3 times x plus 3. X minus 3 times x plus 3 is x squared minus 3. We can write this as limit of x minus 3 over sine x minus 3 as x approaches to 3 times limit of x plus 3 as x approaches to 3. So limit of x minus 3 over sine of x minus 3 as x approaches to 0. The special limit that we have proven is as x approaches to 0. As x approaches to 0. So in order to make 0, let's let x minus 3 is y. Let x minus 3 is y. So as x approaches to 3, y approaches to, as x approaches to 3, 3 minus 3. So that y approaches to 0. So limits, we already say that x minus 3 is y. Limit of y over sine x minus 3 is already y as y approaches to 0. But we can use direct substitutes over here. So that limit of x plus 3 as x approaches 3 is 3 plus 3, which is 6. Then the reciprocal of y over sine x is 1 over limit of sine y over y as y approaches to 0. Reciprocal times 6. We already proved that limit of sine y over y as y approaches to 0 is 1. So that 1 over 1. This is 1 times 6, which is 6. And here we have the fourth example, which is 1 minus cos x over x squared as x approaches to 0. The limit that we have proved is 1 minus cos x, not over x squared. So let's check, or let's try to factorize, or let's try to additional factorization. Find additional factorization so that this is limit as x approaches to 0, 1 minus cos x over x squared times 1 plus cos x, 1 plus cos x. So this is limit as x approaches to 0. 1 times 1 is 1. 1 times cos x is cos x. Minus cos x times 1 is minus cos x. Minus cos x times cos x is minus cos square x over x square into 1 plus cos x. So this is limit as x approaches to 0. Here we have cos x can be cancelled by cos x. So 1 minus cos square x over x square into 1 plus cos x. Limits as x approaches to 0. 1 minus cos square x is sin square x over x square times 1 plus cos x. So we can rewrite this as limit as x approaches to 0, sin square x over x square times 1 over 1 plus cos x, 1 plus cos x, or limit x approaches to 0, sin square x over x square is sin x over x the whole square times limit 1 over 1 plus cos x as x approaches to 0. We already proved that limit of sin x over x as x approaches to 0 is 1. So that 1 square is 1. 1 square is 1 times 1 over 1 plus limit of 1 over 1 plus cos x as x approaches to 0. Cos 0 degree, which is 1 over 1 plus cosine of 0 degree is 1. So this gives us 1 over 2. Okay, the last example is limit of x minus 3 times cosecant of pi x as x approaches to 3. Remember that cosecant is the reciprocal of sine function. So we can rewrite this as limit as x approaches to 3, x minus 3 over sine of pi x. Sine of pi x, since sine function is the reciprocal of cosecant function. And let's x minus 3 is y. In order to rewrite the example in terms of the special limit of sin x over x as x approaches to 0 is 1. Since limit of sin x over x as x approaches to 0 is 1, so that you have to rewrite this as y in terms of x in terms of y and as y approaches to 0. So in the given let x minus 3 is y as x approaches to 3, y goes to 0. Since 3 minus 3 is 0. And the value of x over here is y plus 3. If we shift y or negative 3 to the right hand side. Now, this is limit x minus 3 is y, x minus 3 is y over sine pi times x is y plus 3. X is y plus 3 as y approaches to 0. As y approaches to 0. So this is limit of y over sine pi times y is pi y, pi times 3 is 3 pi, 3 pi as y approaches to 0. Remember that sine of x plus y is sine x cos y plus cos x sine y. So this is given as limit as y approaches to 0, y over sine pi y times cos 3 pi plus sine 3 pi times cos pi y, cos pi y. Then the angle 3 pi. The angle 3 pi is, here we have pi plus pi plus pi, which is in the point minus 1, 0. So that the sine is 0 and the cosine is minus 1. The sine is 0 and the cosine is minus 1. So this is limit as y approaches to 0, y over sine 3 pi is 0. Sine 3 pi is 0. So this is 0 and cos 3 pi is minus 1. Cos 3 pi is minus 1 minus sine pi y. Minus sine y. So the reciprocal in order to rewrite this into the form of limit of sine x over x as x approaches to 0, we can find the reciprocal 1 over, or we can make it the minus with the number 1 over limit of sine pi y over y as y approaches to 0. So this is minus 1 over limit of sine pi y over y times pi. In order to make pi y times pi as y approaches to 0. Remember that limit of constant number is the constant itself. So that limit of constant number is the constant itself. Here we have pi times limit of sine pi y over pi y as y approaches to 0. Minus 1 over pi. Since limit of sine pi y over pi y as y approaches to 0 is 1. This is all for today. Don't forget to subscribe our YouTube channel, Better Tutor. Thank you very much.